Hi again. Let's start from where we stopped last time. We will continue on survival models. So we will add a new notation to it. We started looking at the future, if you remember what we looked at last time. We moved from 0 to time x. So we are given information, conditional probability, that given the information that the individual survived to age x. So now we are not interested in the whole life cycle, the whole lifetime, but we are rather interested in the random variable of the t of x, which is the remaining lifetime to death for an individual who already reached the age x. So always remember this, that given information that already reached the age x. So if you recall at the beginning, we looked at the actuarial notation for expected life, the complete expected life. We used E0, and I told you this 0 here is age. So at age 0. And we give it another O here on top, not or. This is to say it's continuous. What we wanted now is to continue working on continuous. This is not a problem, but to change the age 0 into new age x. So this is the expected lifetime, the expected remaining lifetime, or this is the expected t of x. Let me use a bracket here. Right. So we use E again, E subscript x and O on like superscript, right? Does that make sense? So what's the formula for this one? Well, it's the same thing. It's the same logic. How you calculate the expected random variable. The expected random variable you integrate over like the horizon of the random variable itself. And now the random variable is not x, it's t, right? Remember, it's t, the random variable. X is the age, it becomes constant. So t multiplied. What is the function of t? dt, right? So this is one way to say it, but we can also write it this way, 0 to infinity. We know it's t, again, like it's our variable, it's like the new x, let's say. We multiply it, what f of t, or the density function of the distribution of the remaining lifetime distribution. We looked at it last time. We said it's t px multiplied by mu x plus t dt, right? So this is the one way of doing it. It's to multiply your t with the density function. The density function for the remaining lifetime is tpx. T should be smaller than this. Tpx multiplied by mu. Mu is the force of mortality. Mu x plus t, so the age plus t dt, right? But also we said that you can move from here to here using the integration by parts. You can show this one to be also equal to only tpx dt. And which one to use? Well, it depends on the context. Certain contexts, it's easier to use this one. Many contexts, actually. But other contexts, because there is lots of things that they cross out with each other, it might be useful to use this one. So it's just like the question itself based on it. We'll take a few examples to demonstrate this. We'll take easier ones and we'll take a harder one and demonstrate it. But just to recall what's TPX from last time, we said anything remaining future lifetime, anything related to remaining future time, you have to, it's conditional, you have to divide it by something. So it's the same as if we use s of x plus t. Now this is the complete life one, is s of x, not s of t, right? We need to divide it by s of x. So the survivor function of x of plus t to divided by s of x. So basically what you are saying here is probability to survive here, if you are here, the probability to survive here divided by the probability you already survived here. It's a conditional probability, right? So this one you can log it here and then you calculate your expected lifetime, right? So those really, all of them, you need to know all of these, of course. This one we already know it last time, but the rest are very important, right? Why I'm doing this, just like I tell you, whenever I circle something, it means that you need to memorize as well, right? So those are very important. Let's take example. Let's start with the very easy one. Is the uniform, or let's say the complete lifetime, like the random variable of age at death. X is uniform between, when I say U, it's uniform between 0 and 100. Right. So this is the typical story we have here. So we wanted to compute, you are given the question to compute, instead of 0, you are asked to do 40, the expected remaining lifetime, right? The life expectancy at age 40. How we calculate this one? I mean, you can integrate, it's so simple, but what I wanted you to recognize the fact we established last time, right? Recall what we said. If X is uniform on 0 and omega, then what is T? T of X is the remaining lifetime at age X is also uniform. But it's not all over the whole period, but it's between 0 and omega minus X. Right? You can compute the integration, but to save time, it's simple, because you know that it's uniformly distributed. The remaining lifetime is uniformly distributed over 40, so it's simple. It's nothing difficult here. All you need to do, what's the remaining lifetime? So remaining lifetime, if this is U, then T of X is uniform over 0 and 60. Where I got 60 from, it's 100 minus 40, right? Just to see it. 100 minus 40. This is X, this is omega, right? Once you do that, it becomes 60 divided by, remember, A plus B over 2, 60 divided by, which is 30. Right, so the life expectancy for somebody already reached the age of 40 for uniform distribution, for uniformly distributed life, is simple. It's just 30. Right, that's very straightforward. Now, what is the let's say the question asks you about variance of T of X. Variance of T of X, if you want to do it the integration way, you need to integrate firstly to find the second moment, which is T to 2 multiplied f of T integrated, and subtract from it the expected value. But because we know this is uniform, and uniform has a beautiful feature that its remaining lifetime is uniform. This is the feature that we like. Then we know the variance, the remaining lifetime is omega minus, instead of saying omega, it's again like the same thing, 100 minus X, which is 40, raise it to 2, divided by 12. Where I got this from, it's the same logic, because I'm using this feature here. So this one becomes 60 to 2 over 12. If you do the math quickly, I use a calculator, 60 raised to 2 divided by 2, it should give us 300. That's beautiful, right? And so this is very simple, right? So uniform distribution, the remaining lifetime is uniform, so you do things quickly. Now let's take another example. And now let's say X, or X is, instead of saying uniform, now we're going to use X is exponential. So X is exponential, and for exponential we need mu equals 5%. And what's mu is the force of mortality, right? Other textbook might use lambda. Just if you see it, it's the same thing, nothing different. So I'm consistently, I will continue to use mu. So, but if I make a mistake, I use lambda, it's the same, whatever we use. But mu is 5%. So let's take a few questions. Let's define T of, maybe we can take T of 40. Yeah, is remaining. Well, let me draw it. It's here, 0, 40, and this is T of 40. So the remaining lifetime, right? So the remaining lifetime for an individual who already reached 40 is T40. So if we define T40 this way, let's find one. well, first thing we wanted to find TP40. What is TP40? If you draw it is 0, 40, and we need the survival function if somebody reached 40. So this is TP40, right? So basically the survival function if somebody reached the age 40, what is the survival function? TP40, by definition, we already looked at it. You can use S of x plus t divided by S of x. And x here, just where we get the x, is the 40, right? So our variable is t, and x becomes a constant, right? And S40, remember this is exponential distribution. S of x for exponential on the side is e minus mu t, right? Or x in general. This is the general form, right? So here we have 40, and the t is our x, the variable. So this one can be written is in simple way. Let me give myself more space so I don't. Right. So let's take S40, right? S40, so we take E, and our mu is 0, 5. And now the whole thing 40 plus t divided by S of 40, E minus 0, 5, 40. If you just cancel out, you know, like this one will cancel out with this one, what you are left with E minus 0, 5 t. And this is very similar to this. There is no change between the t of x and x, like the function tpx and the survival function of x. They are the same, because this is exponential distribution. But what if you wanted another one to ask us to compute, let's say, what is f of t? Density function of t for exponential distribution. For this is the density function of the remaining lifetime, right? Density function of remaining lifetime of tx. What is it? Simple. Remember f of t, the definition of it is s. You can do it in different way. Let's take one way. The definition of it is you take f of x, but because we are dealing with conditional f of t, the remaining lifetime is conditional probability, then we always need to divide by s of x, given that you survive to age x, which is 40. Okay. So it's given that you survive to 40. So what is, and this is 40, right? What is what is the this density function of this one? 40 plus t, I mean x plus t here. X plus t, I meant, which is 40 plus t. What is, if you plug in like the density function of exponential distribution, it's mu, which is 0, 5, and multiplied by e minus 0, 5 multiplied by what is x, our x here, or in general, what is multiplied by x, but our x is not x here, is 40 plus t divided by survival function. There is no mu. Survival function is e minus 0, 5 multiplied by 40. By now I assume that you know all, for exponential distribution, you know the different forms of f of t, or sorry, like the density function, cumulative distribution function, survival function. You should know them very quickly, right? So if you do the cancel out with this, what you are left with is 0, 5 e minus 0, 5 t. So this is ft and t. And this is exactly the same of the density function of the whole life. So the whole life and the remaining life, they are the same, because exponential is memoryless distribution. Whatever, whatever is given information is useless. In exponential distribution, whatever the information is given is useless because it's memoryless, what we call distribution. Same logic, but let's take alternative way. Alternative way to compute f of t should give us the same thing. Now remember that when we said mu x is equal to, remember when we said that it's f of x multiplied by s of x. What gives us for f of x is s of x multiplied by mu of x. But we wanted f of t. And this is the same thing as s of t multiplied by mu x plus t. This is by definition. Right? This is by definition, right? Or it can be f of t, but we already introduced it at the very beginning. It's tpx mu x plus t. Different way. I already introduced it here, just when I said it's very important to know. And we already talked it before, right? So you can use it directly here, right? It's nothing difficult here. So we already calculated tpx. If you go back to tpx, this one, right? Remember tp40. So TP, actually let's use 40 here. TP40 is, we already computed to be E minus 0.5 multiplied by T. Now U40 plus T for exponential distribution, it's exponential, right? With constant force. So because it's constant force, so for only exponential, mu is fixed, so which is 0.5, right? And if you do this one, you compare it, compare it with this one, should be the same. We did it in two different ways, right? It's the same. So all of them, they should give you the same same answer, right? But what is CDF now? What number we do? 3. What is CDF? Or FT, cumulative distribution function. What is the cumulative distribution function of the remaining lifetime given its exponential distribution? And in actuarial mathematics, we give it TQX. And our X here is H40, right? And T symbol 1 minus TPX, which is 1 minus, what is our TPX? Is E minus 0.5x. Oh, sorry, T. Right. So it's the same. This is exactly the same. The remaining lifetime random variable and the whole lifetime random variable, both of them, they have the cumulative distribution function if we are using exponential distribution, because it's a memoryless distribution. What is for E040? This is simple. It's 1 over mu. 1 over 0.5 20. 1 over 20. 200. Sorry. What if you wanted to have the variance? Right? What if you want to have variance of t of x for exponential distribution? Because we know it's memoryless distribution, we don't need to do much. It's 1 over mu to 2. So 1 over 0.5 square, which is, if you use my calculator, like 20 multiplied by 20, right? It's the same answer. It will be 400. I mean, you don't need to calculate, because this is 20, multiply it again by 20, it will be 400, right? Does that make sense? So let's summarize here. Summary. If distribution if t of x is if x is uniform on 0 and omega, then t of x is uniform on, instead of 0 and omega, is omega minus x. So all the summary formula I gave you in the previous lesson about the uniform distribution, they are all the same. The only thing, if omega is 100, you subtract from it the x, the age that is given that the person survived to it, right? Another one is if x is exponential, you don't need to do any calculation here. It's the same thing. T of x, let's say exponential, what is this? Exponential with mu, then t of x is also exponential with the same mu. There is nothing it changed. Why? This is memoryless distribution. For memoryless distribution, exponential is memoryless distribution. The given information is useless, right? And this is very important, two characteristics to keep them in our mind. But what about other distributions? We need to calculate. Right? For other distribution, we need to calculate. If it's not exponential, it's not uniform, you need to calculate. So we need to calculate. Let's take one example to see how we can compute some of those relationships. So what I wanted to do is, let's take this example of, let's take example. And the example we wanted is f of x. Now we are given the density function. So sometimes you are given the density function, sometimes you're given the survival function. Whatever is given, you need to play with it. So x over 50. And what I wanted you to see is this is x, it's not t. So this is for the whole life from age 0. And this is for a life between x 0 and 10. Right? So we need to, and the question defined t of x, t of x, or let's say t of x, t of 2, is the remaining lifetime for an individual who survived to age 2, right? The remaining lifetime until death for an individual who survived to age 2. So this is given to us. So the age we are looking at is 2. So we are here, f of x for here, and then we reach 2. We need to go forward, right? It's given that the person survived to 2. Let's do the same questions we did. The first question, TP2. And now it's function of t, it's not function of x. So this is the survival function of an individual who already reached age 2. And by definition, this is we use s of x, x plus t, divided by s of x, right? And our x here is given, it's 2, right? So in order for us to do this, we need s of x. So what is s of x? So we need to find s of x as a step. Well, we know that f of x is given to us x over 50. Did I get, yeah? X over 50 for x between 0 and 10, right? So from here we can take f of x. And how we get f of x? We integrate from 0 to x of x over 50 du, right? And if we integrate this one, u2 over 100 from 0 to x, it will be the answer, it will be x to 2 over 100, and the same x between 0 and 10. Simple. Now from f of x, what we can get is s of x, which is 1 minus f of x. The survival function is the 1 minus of the survival function is the complement, is 1 minus the cumulative function. So this one is becoming 1 minus x to 2 divided by 100 for x between 0 and 10. I mean, you can think of it as 100 minus x to 2 divided by 100. The same thing, right? Right. This is the very same, right? We didn't do anything different here. But now let's go to TP2. TP2, it's already here. Sx plus 2. Let's do it here. Right? Or let's, yeah, Sx, well, we can do it here, right? Let me do it again one more time, right? It's x, s of x, x plus, 2 plus t divided by sx of 2. So let's now plug in 2 plus 2 into x squared, right? 1 minus, let me write this line here, 1 minus 2 plus t raised to 2 divided by 100. S of 2 is 100 minus 2 minus 4 divided by 100. You see what I did here, right? It's simple. I just plug in the values. So these guys will cancel out. So what you end up with, TP2 is equal to 100 minus, let's keep it as is, 2 plus t to 2 divided by 96, correct? Right? 96. Right. So now let's take another question. We did this one. Let's calculate, what if you wanted to calculate ft, oh no, let's calculate, yeah, I just wanted to, yeah, let's calculate, we did TPT, let's calculate mu x plus t. Find mu x plus t. And that is also straightforward, right? Remember, recall how we find mu x in general is equal to, simple, it's you take the f of x divided by s of x. So now let's find what's mu of x. F of x is given to us by the question itself. Let me go back to see what is f of x. It's given to us, it's x over 50. X over 50. What is s of x? S of x, we already also computed it, didn't we? Like s of x here is 100 minus x to 2 over 100. 100 minus x to 2 over 100, right? Now you do little manipulation. This one you it becomes 2, and this one 1, and you take the 2 to the numerator, it becomes 2x divided by 100 minus x to 2. Right? Simple. There is nothing difficult. But remember what we wanted to do. The question asks us to find this guy, not this one. Well, it's simple. Mu x plus t, and let's say the question referring, you remember what x at age 2, right? Let's keep it age 2. At age 2, if you wanted to do it at age 2, is simple. We do, now we plug in 2 plus t, becomes 2 plus t divided by 100 minus x to 2, or x to 2 is 2 plus t to 2. Why x is 2? Because remember, again, like we defined from the very beginning, we defined t2. So we're dealing with x is 2, right? Define t2, the remaining lifetime is 2, right? Keep it as is, don't do anything. But what is, so now this is, it's done. So let's have another question. What if the question asks us also find the density function of f of t of x, t of 2, right? The remaining lifetime. What's the density function of f of t here? Remember that because we're not dealing with f of x, we're dealing with f of t and 2. So we need f of t. Let's keep it t because it's under, sorry, not 2, t. Right? There are two ways. Let's start with the easy one. It depends on the information you have. The easy one is tp2 multiplied by mu2 plus t. This is the easiest way. Why the easiest way? Because we already calculated TP2. What is TP2? Go back. This is it. Remind me how I can carry it. It's 100. If I make mistake, correct me. Is 100 minus t. Let me, instead of keep going back and forth, even my notes, I don't know what I wrote in my notes. Yeah, 100, 2 plus t raised to 2 divided by, 100 multiplied. Let me go back. You see where I got it? This is, just make sure I got it 100. Oh, divided by 96. You see, I made a mistake here. Divided by 96. 2 plus t divided by 96. Now we need to multiply it now with this guy. This is here. We already computed it. It's just in a second ago. T plus t. So 2 plus t divided by 100 minus 2 plus t square. I think if I got it right, yeah. 2 plus t square, right? So now it's easy because you can recognize this. Go out with this one. What you are left with is 4 plus 2t, or actually keep it. 2 plus t divided by 96, which is 2 plus t divided by 48. And this is your ft, the density function, right? It's simple. But I said there are two ways. Remember when I said two ways? Now, alternative way, it's always important to know different ways because sometimes, you know, it's easier to do it one way than another. So we need ft of t. And this is, by definition, it's fx x plus t, which is our x here is 2, divided by, remember, we move from the whole life into the given information. You need to divide by the condition that is given to you, which is fx of 2. Right? Sorry, s I meant, the survival function. Right? So we straightforward, what is the density function, which is given in the question, right? It's given in the question. This is the density function. I go back so for me to see it, but also for you to recall where we got it from. This is the density function. It's x over 50. X over 50, so it's 2 plus t over 50. And what is sx2? It's already here, right? The one I made mistake when I copied it. This is it. No, not this one. It's 100 minus x2 over 100. 100 minus x2 over 100. Which is 100 minus x2, which is 2 to 2. over 100. Right. So this becomes, if we do the math here, it should be the 100 here cancel out with this one. You left with 2, and flip it, it will become 2, let me use the same color. 2 plus t, right? You see what I did? Over 96. And this is your, which is 2 plus t over 48 if you cross. And now let's compare this one with the previous question, right? They should, this previous method, they should get, both of you give you the same answer. Now let's add another question, because this lesson is about, you know, like also we introduce a new notation for expected life. So now the question is to find, instead of at time 0, it's at time 2, the expected lifetime, remaining lifetime at 2. I failed to say something here. For all the remaining lifetime is bounded between t between 0 and 8, because the original one 0 and 10. Now the remaining lifetime, you remove 2 years, becomes 0 and 8. So the question here is to ask us to find it from 2 to the expected remaining lifetime, which is the expected t of t of x when x is 2. And there are also 2 ways. One way is you use integration, so e to 0, integrate from 0 to infinity ft, well, t multiplied by the density function dt, right? And because it's bounded, ft is bounded between 0 and 8, let me keep it here, and then it changed this one into 8, just to remember. It's bounded between, the whole life is 10 years. We already passed 2 years, survived the 2 years, so the remaining life is 8. And if you do this method, is you can write it also from 0 to 8, can be written also tpx ux plus t. Same notation. But whatever you do is, we have, because this is 0 to 8, and your t multiplied by what is f of t, we calculated just in a second ago, right? If we calculated is this guy here, 2 plus t divided by 48 dt, which is for it becomes sorry, I made a mistake here, or no, it should be okay. Yeah, so we have the yeah, it becomes like 2t plus t square and 1 over, let me just, why am 0 to 8 and 1 over 48, let's take it here, dt. Help us. And if you do this one now, is 1 over 48 is multiplied by t to 2, right? Because the 2 in the denominator crosses out with the 2 here, plus t3 over 3. Everything is evaluated here from 0, not infinity, sorry, 8 I meant. 8. If you do that, 1 over 48, let's use our calculator. So we have now 8 to 2, which is 46. Don't need to do that. 8 to 3 divided by 3. Yeah, it's 72 is equal 1.5. I think I'm making a mistake here, but let me double check it with my note. It's expected value. Just can I think I made a mistake. Just 1 second. Oh yeah, so let's take 8 to 3. Oh yeah, I made a mistake. Divided by 3 plus 8 to, oh yeah, I figured out it doesn't make any sense. By 48. Yeah, it's 4.888, right? And this is the expected value of this distribution, right? So it's not really difficult. So again, let's summarize what we did. Many exam questions you will be given the form, usually exponential or uniform distributions. Those you don't need to integrate. You should know the formulas. You can quickly use the shortcuts, knowing that uniform distribution, remaining lifetime is also uniformly distributed, so you basically can go quickly. Exponential is memoryless. It doesn't matter where you start, so it's always the same mu. However, if there are certain questions that you have to integrate, like this one, and usually if I give you questions like this, it would be something like this, manageable, that you can quickly manipulate it, right? So it's not very difficult. But since I told you there are two ways to compute, this is one way. This is one way. Let's do the other way, how we can compute also the expected value. And you need to choose which one is easier for you. The second one is E to O, is you use the relationship is 0 to infinity tpx dx, right? Dt, sorry. And for our case here, it will be 0 to 2, 0 to 8. And what is our tpx? Is this big guy. This one. 100 plus t to 2. So we're gonna take what we calculated here is 100 minus t plus 2 to 2, sorry, tp, let's put it for, yeah, 2 to 2 divided by 96 dt. It's not really hard to integrate this one, but I think that the first one, it turned out for this specific example, is easier. It should give you exactly the same answer, which is 4.889, right? Should give you the same answer. But I mean, the choice between both of them is which one saves you time, which one is easier to do. But both of them, they should give you the same answer. All right, we have one short lesson, and then we can finish this continuous or the survival models. Next, we will finish it quickly, and then we will start getting into the life table, which is very, very important topic.